Welcome to math classes. Let's do some critical questions in binomial theorem. Some of them are practice and some of them are from the JEE and BITSAT questions. Okay. So before coming to this one, you can check the main video, which is a NCERT book actually. All the information and the chapters, exercise, everything is covered in that. Okay. Yeah. Let's get into the critical questions now. Yeah. One of the most common type of questions is this one. Okay. If sigma equal to sigma r equal to 1 to 9 r plus 3 by 2 to the power of r NC 9C r equal to alpha times 3 by 2 to the power of 9 minus beta, where alpha beta are natural numbers. Then what is the value of alpha plus beta whole square? What is the common type in this is you will get a sigma most of the times you get a question with sigma and some expression like this with NCR and some expression. You need to break it and it is very clear in this question. It is very clear. You have to make this in this form, right? Alpha 3 by 2 whole to the power of 9 minus beta means you just need a simplification of this one, right? This is the most common question, simplification of some NCR expressions basically. Okay, so let's do this one. Most of the times you will do similar method in all the questions. Okay, yeah, you can write sigma r equal to 1 to 9 r plus 3 by 2 to the power of r 9cr as I am splitting this r plus 3 divided by 2 to the power of s r by 2 to the power of r and 3 by 2 to the power of r both multiplied with 9cr. So two terms I will get, right? This is my first term here, r by 2 to the power of r. Okay, I will come to this part. This is 9cr. Okay, and 3 by 2 to the power of r into 9cr. Sigma is same. Okay, now this one is 9cr, but I am taking 9 out from the numerator, r out from the denominator, so I am left with 8c r minus 1. Okay, this you should know. Okay, if you are doing this binomial theorem or permutations and combinations, you will know what is NCR, how to get n by r. If you take out, it will become n minus 1 c r minus 1, correct? Okay, so now simplify further now. 9 by 1 of the 2 I am taking out, so 9 by 2. Okay, sigma r equal to 1 to 9, this will become, okay, this will become r cancelled, 1 by 2 to the power of r minus 1, 8c r minus 1. Okay, now plus 3 times r equal to 1 to 9. Okay, 3 I am taking out common. Okay, so 1 by 2 to the power of r 9cr. Now next is, I can rewrite this. This is r equal to 1 to 9. Okay, this is as good as r equal to 0. If I take, this will become 2 to the power of r, correct? Starts with 2 to the power of r, and this r minus will become r, correct? So r equal to 0 to 8, 1 by 2 to the power of r 8cr plus 3 times, this is same. Okay, next, if you see this expression, this is nothing but 1 plus 1 by 2 whole to the power of 8. You will have 9 terms, NC0 to 8C0 to 8C8, starts with 1 to the power of 8 and ends with 1 by 2 whole to the power of 8, correct? That is what this is exactly. Okay, that is what this is exactly. Okay, so I can simplify this first term as 9 by 2 times 1 plus 1 by 2 whole to the power of 8, and second term is 3 times. Okay, here only difference is, here it is starting with r equal to 0 to 8, but here I am starting with r equal to 1. Okay, only thing missing is NC0 term, first term, NC0 1 to the power of 9 is missing. Okay, which I am adding and subtracting, so that I will get this one 1 plus 1 by 2 whole to the power of 9 NC0, which is 9C0 into 1 by 2 whole to the power of 0. This is I added here, so that it has become 1 plus 1 by 2 whole to the power of 9 minus I am subtracting because I added. Okay, now if I simplify, this is very simple. This is 9 by 2, 3 by 2 whole to the power of 8 plus 3 times 3 by 2 whole to the power of 9 minus 1. Okay, now this is just a simplification into the given form. So I will get, basically if I simplify, 3 by 2 whole to the power of 9 into 6 minus 3. So my alpha is 6, beta is 3, correct? So once I know this one, alpha plus beta whole square is 81. 6 plus 3 whole square, which is 81. Okay, so most of these binomial questions you have to do something like this. Okay, and if you see next questions, you will understand, you will do similar way. Okay, next. Okay, if sigma r equal to 0 to 10, 10 to the power of r plus 1 minus 1 divided by 10 to the power of r into 11c r plus 1 equal to alpha to the power of 11 minus 11 to the power of 11 minus 10 to the power of 10, then what is alpha equal to? Okay, yeah, it's almost similar way you will do it here. Okay, so I will call 10 to the power of r plus 1 minus 1 divided by 10 to the power of r as 10 minus 1 by 10 to the power of r, correct? Right? Now I will split this into two terms. Okay, my given expression is nothing but 10 times sigma r equal to 0 to 10, 11 c r plus 1 minus, okay, sigma r equal to 0 to r equal to 10, 11 c r plus 1 divided by 10 to the power of r. Okay, now let's simplify term by term. First we will take the first term and then next term. First term is nothing but 10 times sigma 11 c r plus 1, which is, if I expand it, this will become 10 times 11c1 plus 11c2 up to 11c11. What is missing? 11c0, correct? So I will add 11c0 and subtract 11c0. This will become 10 times 2 to the power of 11 minus 11c0, which is nothing but 10 times 2 to the power of 11 minus 1. Now you have first term. Let's take the second term. Second term is sigma of 11c r plus 1 divided by 10 to the power of r. I will take that 10 out, okay, multiply and divide with 10, numerator and denominator. So 10 is outside, and denominator it will become 10 to the power of r plus 1. Okay, now this is, if I expand, this is nothing but 10 times 11c1 1 by 10, 11c2 1 by 10 square up to 11c11 1 by 10 to the power of 11, which is only term missing is 11c0 1 by 10 to the power of 0, correct? So 11c0 I am missing. I added 11c0, subtracted 11c0. So it will become 10 times 1 plus 1 by 10 whole to the power of 11 minus 1, okay, which is nothing but given expression is simplified to 10 to the power of 11 into 2 to the power of 11 minus 11 to the power of 11 divided by 10 to the power of 10. So from this I can easily say alpha is equal to 10. Sorry, alpha is equal to 20, because 2 is there, 2 to the power of 11, 10 to the power of 11, which is 20 to the power of 11, correct? So alpha is nothing but 20. Okay, similar way we have solved this problem also, same as previous one. Okay, next. If sigma of r equal to 0 to n, r plus 2 divided by r plus 1 times NCR equal to 2 to the power of 8 minus 1 divided by 6, then what is the n value equal to? Okay, so this is also similar to the previous two questions. Okay, first thing is you split it. R plus 2, I will write it as r plus 1 divided by r plus 1, correct? Now it will become two terms. First term is, okay, r plus 1 divided by r plus 1, which is 1. So sigma NCR plus sigma 1 by r plus 1 times NCR. Okay, so first term is straightforward. We know that this is 2 to the power of n, correct? Now second term, okay, take the second term, which is sigma 1 by r plus 1 NCR, which I will write it as, if I divide and multiply with n plus 1, it will become 1 by n plus 1 sigma n plus 1 by r plus 1 times NCR. Okay, now this is 1 by n plus 1 times sigma n plus 1 by r plus 1 into, if I expand NCR, it is n factorial by r factorial into n minus r factorial. Now if I combine with this will become r plus 1 factorial into r plus 1, r plus 1 factorial, n plus 1 into n plus 1 factorial, n minus r will remain same, n plus 1 minus r plus 1 is same as n minus r, correct? So this is same. So this I can rewrite this as, okay, I can rewrite this as 1 by n plus 1 sigma n plus 1 c r plus 1, r is from 0 to n, correct? Now if I expand one term only I am missing, right? I am missing only 0 term, because it is starting with n plus 1 c 1. Okay, so n plus 1 c 0 I am missing. I am added that, subtracted. So this will become 1 by n plus 1, 2 to the power of n plus 1 minus 1. Okay, now my expression is 2 to the power of n plus 2 to the power of n plus 1 minus 1 divided by n plus 1. If I simplify this, basically a simple simplification, it will become 2 to the power of n times n plus 3 minus 1 divided by n plus 1, which is equal to 2 to the power of 8 minus 1 by 6. Now I need to just find out my n value. I can do trial and error. Best trial and error is you check the new denominator. N plus 1 equal to 6. It should be equal, right? Right. So from that you try. I'll get n equal to 5. You substitute n equal to 5 and see whether the equation is satisfied or not. Okay. If I substitute n equal to 5, it will become 2 to the power of 5 into 5 plus 3 minus 1 divided by 6, which is nothing but 2 to the power of 8 minus 1 by 6. That means answer is n equal to 5. Right. This is the answer. Okay. Next. Largest n belongs to the natural numbers such that 3 to the power of n divides 50 factorial. Okay, this is another Olympiad question, 𝑖𝑣𝑒 question, which came in JEE. This is also 2025. And if you are following my shorts on binomial playlist, okay, there are 2 more problems I told, which are straightforward 𝑖𝑣𝑒 questions, which you can solve in few seconds. Okay, this is also actually, once you know, if you have practiced these kind of questions in 𝑖𝑣𝑜+𝑞𝑚, this you can solve in few seconds. Otherwise, it is very difficult. Let's see. See, one way you can solve this problem is counting. Okay, most of the 𝑖𝑣𝑜+𝑞𝑚 questions, as you know, you can solve it using formulas. You can, if you have enough time, you can solve it using counting. Correct. This also you can do counting. 1 to 50. You know how many are three factors, and count all factors and put numbers. How many threes are there in that? Okay, you will get approximately 23s are there. You will get it very easy. But what if this number is, instead of 3 to the power of n, it is, let's say, 53 to the power of n, and the number is 1000 factorial? Then it is very difficult, correct? So for such questions in Olympiad also, I told this Legrand's equation formula. Basically, there is a formula by Legrand which simplifies it to the very easiest way. Actually, okay, you can't find any easier way than this. Okay, you should know this one. This question is coming in JEE. It can come in your BitSat also. So learn it. Okay, so this is the Legrand's formula which you need to understand. What is this? It gives the highest power of prime number p that divides n factorial. This question is exactly same, right? 3 is a prime. So I am asking what is the highest power, that is n, 3 to the power of n, right? N value I am asking. Correct. Highest power of 3 which divides 50 factorial. Exactly same. And the Legrand's formula is like this. If it is e is a function of p prime, in this case it is 3, n factorial is 50 factorial, then I am giving count of how many such 3's are there. Okay, this is nothing but GIF of greatest integer function of n by p to the power of 1 plus GIF of n by p square plus GIF of n by p cube plus so on. Okay, until how many times you will do infinite? Okay, you will do up to you get 0 in the GIF. Correct. In the GIF, once you get 0, then divided by p to the power of whatever next power, you still continue to get 0. Okay, so we will solve this one, then you will understand very easily. Okay, given problem, we need to count how many 3 factors are there in 50 factorial. Okay, so it is e3 n factorial or 50 factorial, I can say, which is nothing but GIF of n by 3 plus GIF of n by 9 plus GIF of n by 27. You can add plus so on, but I will show you that you don't require that you will get 0 anyway. Correct. So this is nothing but 50 by 3, which is 16. Integer value is 16. 16 point something you will get, right? 3 times 16 is 48. So 16 point something. So GIF is 16. 50 by 9, GIF is 5. 50 by 27, you will get 1. And the next one is 50 by 81, which is anyway 0. Right? So I don't need after that. So these are the 3 terms. So 15 plus 16 plus 5 plus 1, which is 22. This is the total number of 3 factors in 50 factorial. So the answer is 3 to the power of 22 divides 50 factorial. See how straightforward question this is from Olympiad into the JEE. Okay, so please keep doing your Olympiad questions also. Okay, you should be in touch with those questions. You can see my videos on Olympiad. You have so many videos, hundreds of videos. Okay, you can check. Next. Okay. If t0, t1, tn represents the terms in x plus a whole to the power of n, then what is the value of t0 minus t2 plus t4 minus so on whole square plus t1 minus t3 plus t5 minus so on whole to the power of n? Oh, sorry, whole to the power of 2. This is, sorry, I am sorry, this is whole to the power of 2 equal to how much? Okay, so this one is simple. Once you know this, x plus a whole to the power of n is equal to nc0 x to the power of n plus nc1 x to the power of n minus 1 a and so on. Okay, these are the terms, right? T0, T1, T2, these are the terms. Okay, you remember these terms map to these terms. Okay, now given expression, it is very difficult. Whatever way you replace, you cannot get into that form so easily. That is nothing but you have to divide this into 2 groups, right? You have to divide this into 2 groups. How can you do this is, okay, let's take a fresh binomial expression. Okay, complex number using, okay, x plus ia whole to the power of iota, I is iota, x plus ia whole to the power of n. Okay, now this one let's expand. It will become nc0 x to the power of n, first one, nc1 x to the power of n minus 1 ai minus nc2 x to the power of n minus 2 a square. It will become minus, right? Because I into I is I square is minus 1 and so on. So this is nothing but t0 plus it1 minus t2 minus t3 minus it3, okay, plus t4, because I into I square you will get here, which is minus 1 into minus 1, which is plus 1. Okay, and so on. So this is what, if I group it into real terms and imaginary terms, this will become nothing but T0 minus T2 plus T4 minus and so on, which is what here, and I times T1 minus T3 plus T5 minus so on, like here. Okay. Only thing missing is square. How do you get square of this one? Okay. If you take modulus, that's what you will get, right? So take modulus on both sides. Okay. Modulus of x plus IA whole to the power of n, which is equal to square root of T0 minus T2 plus T4 whole square and so on whole square plus T1 minus T3 plus T5 minus so on whole square. Now you remove the square root. This is what you are looking at, correct? So modulus of this expression is nothing but square root of x square plus a square whole to the power of n. So if I square it on both sides, this is what I'll get. X square plus a square whole to the power of n is, this is what we are looking at, correct? So the answer is x square plus a square whole to the power of n. Okay. So this is how we should do this problem. Okay. Very interesting. Good problem. Next. Okay. Let alpha, beta, gamma and theta be the quotients of x to the power of 7, x to the power of 5, x cube and x respectively in the expansion of x plus square root of x cube minus 1 whole to the power of 5 plus x minus square root of x cube minus 1 whole to the power of 5 where x is greater than 1. If u and v satisfy the equations alpha u plus beta v equal to 18 and gamma u plus theta v equal to 20, then what is u plus v value? Basically, you need to find out 6 values: alpha, beta, gamma, theta, and then uv. Correct? Now look at the expression. This expression is not so complex. This is a plus b whole to the power of 5 plus a minus b whole to the power of 5. You will get 6 terms here, all positive. You will get 6 terms here, 3 positive, 3 negative. They gets cancelled, 3 negative terms will get cancelled, and the 3 positive terms from here will be 2 times. That's it. Very simple. Correct? So this is a very simple question. You write it, expand it and write it. Okay. So 2 times. Okay. X to the power of 5 plus 5c2, because 5c1 term will get cancelled. 5c2 x cube into x cube minus 1, because this is whole square. Okay. Then 5c4 x into x cube minus 1 whole square. Right? So if we expand it, this is what it is. Expand it further in terms of x to the power of things. So you will get 2x to the power of 5 plus 20x to the power of 6 minus 20x cube plus 10x to the power of 7 minus 20x to the power of 4 plus 10x to the power of 5. Now you know what is the quotients alpha, beta, gamma, theta from this, right? Alpha is 10, beta is 2, gamma is minus 20, theta is 10. Now you form the equations. 10u plus 2v equal to 18 and minus 20u plus 10v equal to 20. Now you solve these two equations, you will get u and v. U and v is nothing but v equal to 4 and u equal to 1. So u plus v is 5. That's the answer. Okay. So this is a simple binomial problem. So if you look at all these problems, binomial is very easy to solve and score marks in JEE. Okay. Next. Let the quotients of the 3 consecutive terms TR, TR plus 1 and TR plus 2 in the binomial expansion of a plus b whole to the power of 12 be in a GP, okay, geometric progression. Let p be the number of all possible values of r, okay. All possible values of r I need to get from this expression. Then second one is let q be the sum of all rational terms of binomial expansion of 4th root of 3 plus cube root of 4 whole to the power of 12, then what is the value of p plus q? There are 2 problems clearly in this, 2 independent problems actually. Okay, solve both of them. First one answer is p, second one is q, just sum it. Okay, so let's take the first one. Okay, the quotient of tr plus 1 is NCR, which we know. So which means quotients of these 3 tr plus 1 and tr plus 2 are in GP, which means tr plus 1 divided by tr equal to tr plus 2 divided by tr plus 1, which means if I write in NCR terms, NCR by NCR r minus 1 equal to NCR plus 1 divided by NCR. If I expand and put it properly, okay, this is what it will become. Simplify it, what you will get is nr minus r square plus n plus 1 equal to nr minus r square. Nr minus r square will get cancelled. N is equal to minus 1. But in a binomial theorem, we know that n cannot be negative number, right? So which means p, there is no solutions. So p is equal to 0. Okay. Now let's check the second problem. Okay. 4th root of 3 plus the cube root of 4 whole to the power of 12 is 12 cr 3 to the power of 12 minus r by divided by 4, 4 to the power of r by 3. Okay. So if you want to get the rational terms out of it, that means there should not be any power, right? Cube root or 4th root should not be there, which means r by 3 should be integer and 12 minus r by 4 also integer, correct? So if r by 3 is integers, what are the possible values? I'll get 0, 3, 6, 9, 12, correct? Now you substitute in 12 minus r by 4 and check for the integer condition. So only two of them will pass. R equal to 0 and r equal to 12 will pass. These are the two rational terms. So what is my rational terms? Q is equal to 12c0 3 to the power of 3 plus 12c12 4 to the power of 4, which is nothing but 27 plus 256, that is 283. So my P plus Q is nothing but 283. That's the answer. Okay. Next. The quotient of x power 70 in this given expansion is 99cp minus 46cq. Then what is p plus q? Okay, now you look at this expression. It is so big. You cannot really find a common term and then equate it to x to the power of 70. Is it possible? No, very difficult. So we have to simplify this. There is no other way. Get into one simple binomial expression, correct? How to do that? Look at the terms. X square 1 plus x whole to the power of 98. X cube 1 plus x whole to the power of 97. That means x square is become x cube. X is increasing power. 1 plus x power is reducing. Correct? So that is in geometric progression. Correct? So now it is simple. This is in GP. Let's call this summation as S. Then this is nothing but A is initial term is x square into 1 plus x whole to the power of 98. My common ratio is x by 1 plus x. Number of terms are 53. Okay, 98 minus 46 plus 1, which is 53. Okay, so my S sum is x square into a into r to the power of n minus 1 by r minus 1, correct? So that's what I did it here. X square into 1 plus x whole to the power of 98 into all this r to the power of n minus 1 by r minus 1. Okay, if I simplify, it's just a simplification, you can do it yourself. Okay, what I'll get is S equal to x square into 1 plus x whole to the power of 99 minus x to the power of 55 into 1 plus x whole to the power of 46. Now this is simple. Only two binomial expressions are there. Okay, now I need x to the power of 70. So take x to the power of 70 from these two terms and quotient of that one. Correct? That's all I need. How can I get x to the power of 70 from this? X square is already there. So I need x to the power of 68 from this first part. Correct? And the second part already x to the power of 55 is there. So I need x to the power of 15 from this binomial expression. Correct? So which is nothing but 99c68. 99, right? 99c68. That is the quotient minus. Okay. Now here 46c15. This is equal to 99cp minus 46cq. That means my p is 68, q is 15. So my p plus q is 83. That's the answer. Okay. Hope you understand this problem. Okay. These are the good set of questions which will cover most of the concepts of binomial theory. Okay. For JEE and BITSAT and other engineering entrants. Okay. So practice more. I'm anyway doing my shorts and videos. Okay, keep doing everyday problem also, which I subscribe to my channel. You will get your everyday problem. Okay, thank you.